Yes. Oh, 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 yes. 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 Hello, everyone again, and I am Satoshi Tagomori, and I will talk about Norikra and in the details of Norikra and in this session and in this 15 minutes. So I am not so nervous because this is my third English talk. So and I'm got calm and rather than morning stop. Yes, and I am Satoshi Tagomori, and also known as Tagomoris. And this is normally for many times, and I used this slide for my self-introduction. And yes, and morning session is very specially created for keynote. Yes, and okay, and the one thing what you must learn today is Norikra, not Norikra. I done a mistake to submit this talk on a web page, and maybe in your pamphlet, and this session will be written as Norikra, but it's mistakes, and the correct name is Norikra. I'm very sorry that I did a mistake. So today's topics, and I will talk about the basics of stream processing and stream processing with SQL and variations of stream processing with SQL, and the details of Norikra and overview of Norikra and Norikra's and features and queries and use cases in some production environments. Okay, and stream processing, and these are stream processing and benefits I talked about in this morning session. Less latencies and less computing power or no query schedule management and by stream processing. Okay, data flow and latency, and in batch processing, and we should yes, and we should process the batch processing platforms process these data, all of processed data just after the data is written, and then processing framework starts to read the data and process their queries. But stream processing, at first, and we register the queries and before the start of data, and the one event arrives and query and process and that events, and so on. Stream and query executions are incremental model. On incremental model, so that provides less latency. So if data window was finished, and then just after the data window finished, and by incremental query execution, stream processing is already finished. And another topic, queries for stored data. At first, we must store all data on storage systems. That is a very normal, that's very normal. So, and then we write queries like this. And this is very simple SQL to scan the and the fields of V1 on V2 on V3. And then we can write another queries to and scan query on the V1 and V2 and V4. But finally, V1 and V5 and V6 fields are not used in any queries. But we must all data and store. But we must store all data on storage systems, if it used or if not used. But stream processing, and we write all of queries, and that's related on that stream data. And then, if stream data arrived one by one, and then all of queries and fetches the required data from these stream events, and unused fields are immediately discarded. So all data will be discarded right after insertion into each queries. So, and we have not to maintain any storage systems about stream processing. That is the basic of stream processing platforms and maintenanceability. Okay, and it's another topics and incremental calculations model. And stream processing queries, and all of stream processing and execution is have an incremental calculation model. So, if one event arrived and query execute and query and execute the query fetches and values, and then calculate these queries and incremental changes immediately, and then update as internal data and mapping in memory immediately. So, and if value 1 and value 2 is also both of V1 and V2 is true, and then update and the previous status is 0, and update update to 1 by incrementally. So this query repeats this process for each input event, and then finally, we can get the final status of this query and window time window, end of this query time window. This is just equal to these queries and finally final results. But this internal results table is updated incrementally. So I don't I do not describe that. And this table is stored in memory. So if these group-wise variations, or if you use count distinct or any other functions to require very large memory, very large result set, result rows, result records, if it floods from memory space, this query will be broken. So, in stream processing, we should not to write write queries which requires very large memory spaces. Okay, and stream processing requires data window, and data window is the target time or size range of queries. in batch processing, and of course, you will be write and any where clause like this, and date time and equal or rather than 2014 and 9:13 or and 30 o'clock 13 rather than or and date time less than 14 20 00. Yes, this is a very and common equality or equality synthesis for logging for queries and against and logged data. But in stream processing, and we cannot specify any specific date time or timestamp. And instead of that and where clause, we should specify any data target window, like calculate this query every 15 minutes. So to write this specification, we need the extended SQL, like this. This blue specification is the extended SQL is the window specifier that is included in an extended SQL and syntax. Okay, the existing stream processing with SQL systems software. The SPAR. Do you know SPAR? No one knows SPAR. Okay, good. SPAR is a Java library to process and stream data using SQL. But this is a library, not server software. So if we want to use this SPAR, and we must implement any server software, any server daemons in any server software, that's using an SPAR. And SPAR requires schema for each data stream and queries. Schema and SPAR is an open source software and licensed under GPL v2. Okay, and SPAR has an SPAR DSL called as an SPAR EPL. That is very simple syntax like SQL, and that is like this, and select height and weight from table where age larger than 30. That is very simple, and if any events arrived into this SPAR EPL, and that events have an age value larger than 30, and then SPAR EPLs and this query outputs are single events with height and weight immediately. That is very simple model for for select query for each all events without data windows. And counting. For counting and counts records grouped by height and value for events with age larger than 30. That's if this query and we want to execute this query on normal and RDBMS, we can write these queries and select height, count after as C from table and where age larger than 30 grouped by height. This is very simple syntax, but with SPAR EPL, this query doesn't ever produce results because this query is not specified for data window and how long this query should be count and records. So this, if and once this query registers, this query will wait and all events and input events and infinitely. Yes. So we need a time window, data time window. So we should specify the stream processing query within data specified window. So count records grouped by height value for events with age larger than 30 per every 1 hour. This is very important. And this beige and specifier and dot win colon and time under batch and 1 hour is time window specifier. And then this query produce results every 1 hour. This is very simple but important. Do you understand? Understanding? Okay. Yes. And with and without schema. And previously I talked. SPA EPL requires schema. So in schema whole data and schema whole data schema whole data means two means, and schema whole data have two means, and one is strict schema, like an RDBMS, like an predefined fields with types, or if input data does not have any field defined in schema, RDBMS relational database rejects its input data. On the other hand, schema on read is another way to handle schema whole data, and like many of Hadoop processing engines. Yes, and in schema on read systems, and once processing engine try to read non-fields if exists. If the fields defined in schema not exist, and this Hadoop Hive or another processing engine just ignore these fields and replace with null value. It's in schema on read systems. But in schemaless data, in schemaless data systems, any field may exist or not, and any types and two or more types may comes to one field name, like age. Age may be an integer value, but in curious situation, an age may be a float value or double value. But schemaless data systems and all data and all types, all fields, all field set, and any field without any field set, and with or without any fields, or any types and any types and any type values are welcome, are accepted. And of course, we cannot handle any types of data, so an implicit or explicit conversion may occur. So the important thing is the schemaless data fits for the services under development. Of course, under development the development process of internet services, and we always changes any log record and contents or types or structs. So we cannot tell any changes of log contents or log structures to the data analytics platform managers or data analytics platform engineers. So data and the data analytics platforms must be able to accept any data or any data structure from many various services under development. So, and we think that the schemaless data and processing system is very important and very important for all internet services, including us. So stream processing and schema. So queries at first and data seconds is the stream processing. So queries expresses that this query fetches what field and what that field may be the type of an integer or string by operators. If v1 and like and string value, then the f1 or v1 may be string. So, and we can assume the field sets and its types by query expressions. So, that is the data analytics systems and systems. That is the future. That is to be that is the data flows to be realized. And events come from many various points of each services, like an API endpoint or billing services. And these data are mixed into one stream, one schemaless stream. And then queries, and each queries fetches each required values and required fields from these schemaless streams. By this situation, in this situation, query B does not require to know all of field sets, except for example, query A using field A, B, C, and query B using D, E, F. Then query B does not require about the field A, B, C. That is very simple and easy to write queries and easy to add any other events that is newly required. And then I developed a software to realize that system. That is Norikra. Excuse me. Yes, that is Norikra. Norikra is a schemaless stream processing with SQL. That works as server software, runs on JVM, and an open source software licensed under GPL v2. And this URLs are Norikra's document site and source code repository. Okay, and Norikra is in schemaless event stream processing systems. So we can add or remove data fields whenever we want. That is very important for services under development. And SQL. And we can add or remove queries anytime and we want. So we don't restart Norikra to add or remove queries. That is different from Spark applications or any other stream processing systems. And with Norikra query, and we can use joins and subqueries and user-defined functions, or yes, and Norikra query can handle truly complex events. Truly complex events with nested hash or array objects, and we can access directly from Norikra queries. And I will show you examples later. And then Norikra have an HTTP RPC APIs with JSON or message back data bodies. Okay, and in addition to it, and Fluently plugin. I am developing a Fluently plugin for Norikra. So if you are using a Fluently, you can easily input its data into Norikra. Okay, and how to set up Norikra? Norikra, and previously I said that storms and deployment and steps is very long and complex, but Norikra is very easy to set up. And at first, install JLB. That is, you can just download JLB.tar.gz and extract it and export and pass an environment variable within this JLB binary. Or if you are using an RVM or another Ruby and runtime management tool, and you just do the RVM install JLB and then RVM shell and JLB and then this is the first step to use Norikra. And then second step, you just type gem install Norikra. Gem is the package management systems of Ruby libraries. And gem install Norikra is distributed as a Ruby library. So you can just install gem install Norikra. This is the only one steps to install Norikra. And then just after installation, you can launch Norikra by Norikra start. That's all. Okay, and the Norikra have some interfaces like a command line interface and web UIs and HTTP APIs. And for command line interfaces, Norikra client command. Norikra client command is automatically installed with Norikra servers, and you can install separately by Norikra client module independently. So Norikra client command have many subcommands to operate Norikra itself. And web UI. And if Norikra server is running, you can show server status or show or add or remove queries on its web UIs. And if you want to control by your own programs or programs or any other separated servers, you can use an HTTP API by sending requests with JSON or message back. Okay, this is the Norikra queries and details. This query, and in Norikra query, we call as target and instead of tables or streams. Target is virtual tables and like RDBMS. This query is completely works. And if data arrives, and then this query projects and name and age and output and the records. This is very simple. Then if this, this example is, yes, I see. As if input event does not have age attribute, this query just ignore these input events. This query requires and fields like a name and age, but this input event does not have age, so this query does not process this event. And then, of course, we can use where clause. For example, input events, the current and field, the value of current field of this input events is type A, and this query requires current equal type A. So this query outputs this result. This is also very simple. Yes. And of course, the current value is not type A. This query does not produce any outputs. Okay, and aggregation. This example is described previously. So if we load this query select age and count and from events dot time batch 5 minutes group by age, and then this query outputs records every 5 minutes, like an age 34 count 3 or and age 33 count 1 and blah 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 for any age values and found in input events. And next, if we want to know the maximum number of age, we can, of course, we can search this and results and calculate the maximum number of age, but we can also just add this query, select max age as max from events.mean time batch 5 minutes. This is also very simple, and input events are processed by both of these queries, and both of these queries produce these own results by this, like this, and age and count, age and count, age and count, and max 51. Okay. And for the nested events, if we want to bundle the user and attribute into user, the single field user by okay, and that and server-side application have an user object, and to output logs into the streams. The flattening of records is very complicated and boring. Yes, boring. So, and we want to write these data like this. So, and user field and have an JSON object and with fields and age and corp or address, and in another field attend, we want to have the Boolean value array of Boolean values like true, true, false, true, true, false, true. Yeah, and if you want to process the data like this, you can write SQL by like this, user.age. This user.age fetches the events, fetches the data of the value of user, and then the age and the value in the user object and field of user. So this user.age fetches the value 34. of course, and we can fetch the array values like this. Attend.data0. Attend.data0 is true and attend.data0 is true. If we write attend.data2, this will be false. Okay, so we can handle these events by handling this and complex nested events. And yes, application and program engineers and server-side and application programmers can write the logs and more casually and not to they are not needed to think about how output yes, and I want the server-side application programmer not to worry about the logs format or structure restrictions. So the freedom and the freedom for log structure is make faster to make the server-side implementation faster. That is very important for internet services. Okay, the last section. Okay, the use case. I will talk about 3 use cases in the 2 use cases in line, and the last one use case is out of line. Okay, out of line. And the first use case is an external API call reports and for partners, and we are serving the Line Business Connect. Line Business Connect is the service for our partners. If the Line user send the messages to the offshore accounts of our partners, and we receive that events in Line messaging server, and that message transferred into the channel gateway servers. And channel gateway servers sends these events to our partners and Business Connect server over API. And our partners can decide how reply that events and can send reply over channel gateway over Business Connect API. That is a public service, public button, and closed customer for closed customer services. But this API and this system is working now. And then we should make a report of the user's Business Connect server, API, endpoints, and status. So in many cases, and our channel gateway server sends API call to our partners and Business Connect server, but this server does not respond anytime. So, and we should show the API call times and response times and its status summaries to our customers on our consoles. So, and that's it. That is a Business Connect server API report consoles, and the error time span, and the error detail information, and an error count. And we should aggregate these events with time error details. And then, at the same time, any error occurs, and we send email to our partner's email address. This is implemented in Norikra, and the channel gateway server cannot send any requests into our partner's server. Our channel gateway server logs these events and sends over FluentD. FluentD insert these events into Norikra, and Norikra aggregates these events by this query. This is very simple, and select channel ID is the ID of partners, and the reason and detail and count and all of error records, and timestamps. Timestamp is the most earlier timestamp and the last timestamp. Then group by channel ID and reason and detail, and then moreover and having count larger than 0. And if any event occurs, this query does not produce any results records. That is very simple and understandable. Okay, and another use cases. This is the prompt reports for ad service consoles. And this console is also for our customers of our ad services. And application servers send these impression logs into FluentD, and FluentD writes these logs in both of Norikra and HDFS. And then Norikra query will produce the prompt report event results, and the console service fetches these result events very frequently. And then after 0 o'clock, and the console service executes the Hive query at once to produce fixed reports, daily fixed reports. This is the Hive query for fixed reports, and we are writing stream data as JSON on HDFS. So, Hive query must use and get JSON object function to fetch any values. But this is a very understandable, maybe. But in Norikra query can fetch any structured data. So this query is very simple and understandable. And this query select campaign ID and region and language and all of event counts and distinct of member IDs. Distinct count of member ID as unique users. And where type equal click. So click and this query counts and click events only. Another view or any other events are not calculated with this query. Okay. And the last use case is the real-time access dashboard on Google platform. This is the use case from Googler Kazunori-san, and this system is to show the access log visualization on Google spreadsheet and count using okay, and this is a variation of Lambda architecture platform and using Norikra in 2 levels. And finally, for the batch layer, and using Google BigQuery, like this. Oh, this is the final dashboard and view in Google spreadsheet and Google Apps script. These graphs are updated in real time. Okay, and this is the configuration. This is the configuration. And each web server, Nginx, writes these access logs into file and fluently fetches these access logs records, and then Norikra servers are executed on every web servers, and this fluently writes these events into local Norikra server, and Norikra server aggregates these log events in very short window, like 1 second or more shorter. And then Norikra fluently fetches that's Norikra query results, and we send into another Norikra query, another aggregate server. On the other hand, all of access log events are directly sent to BigQuery. So this upper side of access logs means all events of access logs, and the lower side of Norikra query results means the aggregated results per one node. And then these servers are very highly distributed, like 70 servers. And then all of these logs are inserted into Google BigQuery directory, and the result count results of per host are sent to an aggregate server, and aggregate server can produce the total count of all servers, and the results will be written in Google spreadsheet. This is the two-level aggregation. This system does two-level aggregation, and this multi-level aggregation is very very powerful design to highly and huge amount of data with stream processing. Okay, and that's all. And I hope that many users and many developers use Norikra. And with Norikra, many more queries are will be written. And your systems with Norikra become more simple and gets more simplicity. And the results of these queries have less latency. Okay, thank you very much. Any questions? Oh.
How could we prepare the HTTP request to use the Norikra?
Norikra. Yes. How we can send an HTTP API request into Norikra?
Yes, use HTTP to query to use the SQL query.
How? Sorry,
in your presentation, you say we can use the HTTP. Right?
Sorry, this and your desk mics are not clear for us, but HTTP requests. How we register the HTTP Norikra query over HTTP API?
Yes.
What you mean?
Yes.
Wait a minute. Okay, this is the part of Norikra's documentation side, and we can send this. Oh no, this is this document does not contain the query registration. Oh, sorry, does not. This document does not have any query registration, but this is a very this is an example of an HTTP APIs, and this is an fetching of an query output, but like this, and get or post and send get or post method with an content type application JSON, and the content body requires a query name. Just query name and means what this request, what's the name of an query. This request fetches the query name results from this. This query name means the this query name specifies the this query want to fetch the results from. Yes, and if you want to register the query name and group name and expression. So you should send a post request with the query name and group name and query expression with the select expression query expressions. Okay.
Thank you.
Yes.